All right, in this video, we want to solve these polynomial inequalities over here. So let's get started with the first one over here. This is a quadratic inequality. So the first thing you want to do is you want to make one side equal to 0. I'm going to bring the 16 to the other side. So x squared minus 6x, 9 minus 16 is negative 7. Then it's greater than or equal to 0. Then you want to factor this. So what multiplies to negative 7 and adds to negative 6? That's x minus 7 and x plus 1. And then we can either solve this using a number line or a sign chart. I prefer to do a number line. It's a lot quicker and a lot easier. So I'll start by just getting my zeros for this equation, which are positive 7 and negative 1. And these are the numbers that are going to go on my number line in order. So negative 1 first and positive 7 second. Then I want to test each of the intervals. So I'll start with testing this interval over here. I'll start with basically f of negative 2. And I'll do this in my calculator. You can sub it in either of these two equations. It doesn't really matter. And if I put this in my equation, I'll get positive 9. And positive 9 is greater than 0. So that's a good range over there. Next, I'll test a value in between here. I'll test f of 0. F of 0 is just negative 7. You can do that mentally. Negative 7 is not greater than or equal to 0, so this range is no good. And then the last range over here, I'll test positive 8. So f of 8, again, I'll do this in my calculator. Although you could do it mentally as well, it's not too difficult. Positive 9, and that is greater than or equal to 0. So I have two possible intervals that are good for this question. This first interval here is just x is less than or equal to negative 1, or x is greater than or equal to 7. These two intervals are the possible solutions to this question. Let's go to the second question over here. Again, we want to factor this. I can start by common factoring out an x, and I'm left with x cubed minus 8. And this is a difference of cubes. So x, this is just x minus 2. Basically, I cube rooted those. And then this is a square, which is just x squared plus 2x plus 4. I'm not really going to explain difference of cubes in this example, but you can go and check out a video on difference of cubes of my channel if you need a bit of practice with that. This is impossible to factor further. So over here, my solution is x equals to 0. Over here, my solution is x equals to positive 2, and this one will have no solutions over here. So now I want to do my number line again, 0 and 2 over here. So I'll start by testing the first negative range here. I'll test negative 1. And I'll put this one in the first equation because that's much easier to type in my calculator than the last one over there. So negative 1 to the power of 4 minus 8 times negative 1 is just positive 9. Is positive 9 less than 0? Nope, it's not. So put an X over there. Then I will test positive 1 next. F of positive 1 is negative 7, which is less than 0. So this is a good range over here. And next, let's test f of positive 3, final range over there. Again, I'll just do it in my calculator. which is negative 15, which is also less than 0. So this one is a good solution over here. So again, we have two good intervals. The first good interval is between 0 and 2, and make sure you just use less than signs because there's no equal sign in the question. And then the second good interval is just x is greater than 2. Okay, let's go to the third question over here. Again, I'm going to start by moving the 6 to the other side so that I can make one side 0. And now I have to factor this with synthetic division and factor theorem. No other way to do it. So I'll start by subbing in 1 into this equation. F of 1 is going to be 0. So I found my first factor. So I'll do synthetic division next. And I'm not going to explain synthetic division in this video. Again, if you need to figure out synthetic division, go and look at the videos on synthetic division on my channel. Bring down the 1. 1 times 1 is 1. 5, 5, 6, 6, 0. Remainder of 0, so we're good. So I can rewrite this equation in slightly factored form as x minus 1 times x squared plus 5x plus 6 is less than equal to 0. And I want to factor this further. So what multiplies to 6 adds to 5? It's just 2 and 3. And then I want to use my number line to solve this. X equals to 1, x equals to negative 2, x equals to negative 3. I'll put these on my number line. So negative 3 comes first, negative 2 comes second, and 1 comes last. And now I'll test the 4 intervals. So I'll start with testing negative 4. Then I'll test negative 2.5. Then I will test negative 1.5. And last I will test positive 2. So one value for each of the 4 intervals. I'll put this one in my factored equation. It's a bit easier. So let's start with negative 4. And I get negative 10. Negative 10 is less than equal to 0, so that's good. Then I will test negative 2.5 next. And I get 7 over 8 or whatever it is as a decimal, which is greater than 0, so this is not good. Test negative 1.5 next. I'll get negative 15 over 8, which is less than 0, so this is a good interval. And last, I will test positive 2. Which is positive 20, which is not less than or equal to 0. So again, two solutions over here. First solution is x is less than or equal to negative 3. And second solution is between negative 2 and positive 1. And let's go to the last question of this video. Again, I want to factor this. Now you can factor this with synthetic division, but you have to do it twice. If you notice, this is similar to a quadratic equation, except the exponent is 4 and 2 here. So we can factor this with our man method again. What multiplies to 4 and adds to negative 5? It's negative 1 and negative 4. So I make this x squared minus 1 and x squared minus 4 a lot quicker to factor like this. And I can do difference of squares on both these brackets, x plus 1, x minus 1, x plus 2, x minus 2. Then I have x equals -1, x equals 1, x equals -2, and x equals to +2. And then I just have to do it on the number line really quick. So I'll start with testing f of -3. And this one I'll put in my original equation because it's a bit easier to type. Get that as 40, which is greater than 0, so this one is good. Next, I'll test f of -1.5. Which is -35/16. That's not greater than 0, so that's no good over there. Then I will test 0 next. It's +4, so that's a good interval, and I will test 1.5 next. Which is again -35/16, which is no good. And last I'll test +3, which should just give me 40 again, but I'll double check to make sure. Yeah, it's 40, which is a good. So I have three solutions for this final question here. First solution is x is less than -2. Second solution is between -1 and +1. And final solution is x is greater than 2. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.